Welcome back from the break, folks. I hope you got to move around a little and digest all the information that we covered in the first two relatively heavy modules. In Module 1, we got introduced to the concept of artificial intelligence and the different applications of AI. In Module 2, we got to look at one such application, machine learning, and we got an insight at how we could build out the solution inside of Microsoft Azure. Moving on to Module 3, we'll be exploring the fundamentals of computer vision. Computer vision is one of the core areas of artificial intelligence, with a strong focus on allowing AI to receive visual input and see the world to make sense of it and allow us to build out applications and solutions. In Lesson 1, we will discuss the concepts around computer vision and how it functions, and then move on to discuss the solutions in Microsoft Azure that can help you to integrate computer vision workloads such as facial detection, object recognition, and analyzing forms, and several others into your own applications in Lesson 2. In the first lesson, I'll talk about what is computer vision and give you an understanding of how computers receive visual input and some common applications of how this input is processed for useful work. So, what is computer vision? How do computers see? Humans, we use biological eyes to see and process images in our brains to understand the world. Computers use cameras to obtain visual input through digital images such as photographs, live camera feeds, or recorded video files, and then process these incoming images and video feeds using software models. AI applications are then further capable of making sense of these images by using patterns that they've observed from past samples, and they assist in carrying out various tasks, such as recognizing what's in the image, sorting out which part of the picture certain objects are occupying, etc. An image is separated into an array of pixel values. This is how it's segmented. And every one of these pixels is providing information in the form of numeric values, indicating the color intensity in every pixel in the image. These values are then used as features by the machine learning or AI to process and understand the image. Each digital image is represented as an array of numeric values indicating the color intensity of each pixel in the image. Sometimes images are converted to grayscale for ease of computation. In the case of color images, there are 3 layers of pixel values for red, green, and blue intensities. You can then use these color intensity values just like any other data as features to train a machine learning model or to apply transformations and calculations to analyze the image data and find patterns in it. So by processing these images as arrays and using those features to match patterns, computers carry out a variety of tasks. Let's look at some of them. We will look at 6 different applications of computer vision. Most computer vision solutions are built using a combination of machine learning models and some advanced image analysis techniques. They are all based on the visual inputs from the cameras, videos, or images, like you saw on the previous slide. Common applications of computer vision include the following. First, we have image classification. An image classification model uses the features it locates in an image to predict a class label for that image. Essentially, image classification models answer the question, what is this an image of? By observing the array of pixels and their features, an image classification solution is able to match it to past images they have been trained upon. For example, in this image, based on the shape of the vehicle, the color, perhaps the advertisement on top of the vehicle, the algorithm has determined this to be a taxi. Based on data it has been trained with in the past, this is similar to taxis that it has seen in the past. Of course, there are endless applications to this capability. You could recognize fruits, machine parts, damaged machine parts, animals. The possibilities are endless. Second, we have object detection. Object detection models are trained to classify individual objects in the image and to indicate their location within the image as a bounding box. In this image, you can see a bounding box shown where there is the image of the bus, where the car is located, where the cyclists are. For example, you could expand the traffic monitoring solution to detect the presence of multiple classes of vehicles in an image. Object detection models are used to answer the question, what objects are in this image and where are they? Next, we have semantic segmentation. Semantic segmentation models are an advanced kind of model that classify individual pixels in the image based on which object they belong to. Semantic segmentation down to the individual pixel for that identified object. For example, the traffic monitoring solution might use a semantic segmentation model to overlay masks on the image to indicate the pixels that belong to the bus, pixels that belong to the car, pixels that belong to the cyclist with different colors. Semantic segmentation answers the question, which pixels belong to which object? Another situation where you might have seen this happening is during a video call on Microsoft Teams. If you were to choose to blur your background, the application would locate every pixel that is you and keep you looking sharp while blurring the rest of your background. When might you use one over the other? As you can imagine, each of these might require a different amount of processing capability. For example, semantic segmentation is going to be much more computationally demanding than the other two. And there are applications which might require each of these capabilities. For example, you can use semantic segmentation in medical scans to identify exact shapes and perhaps positions of tumors so they can be better targeted for treatment. So every application has its own purposes and uses. Next, we have image analysis. You can build on object detection and classification models to perform image analysis, generating captions and tags based on the contents in the image. So it's a combination of these techniques to identify each of the objects in this image and then carry out classification on each object. In this image, you see that it has recognized a person and a dog and a street, and it has put them into a context and says a person with a dog on a street. Next, we have face detection and recognition. Face detection is used to identify the location of human faces in an image. Further analysis can be performed on the faces to determine the location of facial features. And that is how you have those bounding boxes when you're taking a photo, when your camera automatically changes its focus to make sure faces can be sharply seen on photos. And also when you're tagging on social media, it can provide suggestions based on past tags that you've provided. And last that we're going to share in this session is optical character recognition, or OCR. An OCR model identifies regions of the image that contain text and extracts them. So in this image, we can clearly see Toronto Dominion Bank as the name of the building at the front, as highlighted by the bounding box. So please understand the differences across these 6 applications well, because I'm pretty sure you will be tested on them in the AI 900 examination. And we'll touch a little bit more on each of these in the upcoming presentation. These are the services under each type of vision service, namely computer vision, custom vision, face detection, and form recognizer that you can deploy on Microsoft Azure. And we'll be talking about some of them in the next lesson and performing a computer vision demo at the end of the module. Now that you've looked at some basic concepts of computer vision, let's see some of the services that are available for you to use on Azure. The first of which is the image analysis with computer vision service. Now that we know what cognitive services are, we're going to look at some of them in detail. The computer vision cognitive service provides a pre-trained computer vision model that you can use to analyze images. This pre-trained model can detect and locate over 10,000 classes of common objects. It can then generate an automatic caption for that image and a set of relevant tags that relate to the contents in that image. Tags can be very useful if you need to index images and search for them in the future using relevant keywords. The service can also detect and analyze human faces that show up in the image. The computer vision service can carry out content moderation by identifying images that contain adult, racy, or gory content. We've heard reports of PTSD suffered by human content moderators. So some of this work can instead be offloaded to these cognitive services to free up humans for more value-adding work, or to only be brought in for those instances where the system's confidence level is a bit lower. It can also detect and extract text in an image. We'll explore this more in depth later in the module. Given an image like the one on the right, computer vision service can analyze the image and generate the following. It can pick up common objects in the image, things like jeans, people, shoes, sidewalks, and tag them. After that, these objects are put into context to generate a suitable caption. Additionally, it can also detect any text or faces in the image and identify the presence of adult, racy, or gory content. In the previous solution, we saw that image analysis can locate over 10,000 classes of objects off the shelf. But what about when you have a very niche application of image analysis? Sure, the computer vision service can recognize a car from an image, but it may not necessarily be able to distinguish a Mercedes from a BMW or a Ferrari. All of them are just going to be identified as a cars. Now let's take a look at custom vision cognitive services, which enables you to train a custom model for either image classification or object detection. You will classify these images yourself to train those models to then be used for future predictions. And in this case, you have to upload the sample images of different types of cars to the custom vision service, for example, and tag them to the appropriate labels. And in this way, you'll be able to train the model on which images to contain a Mercedes, which images contain a BMW, or which ones contain a Ferrari. So the more images you train with, the better the models get at recognizing the object. And after training that model, you can publish it as a service for applications to use. The service provides a web-based portal in which you can upload your own images, label the images or the objects in them. Below, we have labels shown for where the banana, the orange, and apple are clearly defined. Similar to the bounding boxes that we saw earlier around the buses, cars, and cyclists, we can train and deploy the model now. You can then consume the model from a client application using its model ID with the endpoint and key for the resource in which you deployed it. The prediction model can be trained in 3 easy steps before deployment. We just need to upload the images and tag them. We need to train the model and publish and consume the model. Next, we have face detection. Face detection is an area of artificial intelligence in which we use algorithms to locate and analyze human faces in images or video content. Face detection involves identifying regions of an image that contain a human face, typically by returning bounding box coordinates that form a rectangle around the face. Facial analysis moves beyond simple face detection. While the custom vision service provides some basic face detection and analysis, the face service offers additional capabilities, including detecting certain attributes of the face, such as the amount of blurriness of the face in the image, the exposure of the face, whether the detected person is wearing glasses on their face, the 3D orientation of that face, the visual noise detected in an image, and whether there are objects blocking parts of the face. One way that Microsoft has put its fairness and transparency, responsible AI principles into action is with continued updates to the face service. The cognitive services team is retiring face service capabilities that target sensitive attributes, things like age, gender, and emotion, which, if misused, could further discrimination. You can learn more in the link in your additional resources document. Only Microsoft managed customers can continue to access models trained to identify specific individuals based on the location of facial features and models to compare faces for similarity. Common applications of detecting faces include building security and access, social media tagging. For example, Windows Hello on my laptop allows me to log in to my computer using my camera. We've already discussed the computer vision service and its use in image analysis. Now we're going to discuss its optical character recognition capabilities, or OCR for short. OCR is the ability to detect and extract text from images. The ability for computer systems to process written or printed text is an area of artificial intelligence where computer vision begins to overlap with natural language processing. You need computer vision capabilities to read the text, and then you need natural language processing capabilities to make sense of it. The foundation of processing printed text is optical character recognition, in which a model can be trained to recognize individual shapes as letters, numbers, punctuation, or other elements of text. The ability to recognize printed and handwritten text in images is beneficial in many scenarios, such as note-taking, digitizing forms or medical records and documents, scanning printed or handwritten checks for bank deposits. Digitizing allows you to archive and query this data with much greater ease. So you can imagine the benefits of that, especially when it comes to applications like medical data, when you can start to spot patterns in patients' data, things which may not necessarily make sense as a single data point, start to join up when you can use machine learning, and that starts with digitizing data. There are two different services that you can use for this purpose, based on how much text you're trying to convert or extract from that image. OCR API is used for quick extraction of small amounts of text. It is pretty immediate. Or you can use the Read API when you have an image that is mostly text. Things like documents or pages of a book or meeting minutes. Finally, we have the last service that we're going to be looking at, the Form Recognizer. This service builds on the OCR capabilities of the previous example and has the additional ability to conceptualize the form fields. For example, identifying specific types of data such as addresses, phone numbers, dates, times, and quantities. It can also understand the relationship between field labels and values. You can use Form Recognizer to train your own custom form extraction models based on your scanned forms. Or you can use the pre-trained receipt model to extract information from scanned receipts. A common problem in many organizations is the need to process receipts or invoice data. For example, a company might have a special form for onboarding new employees, which might require submissions of electronically scanned documents or other information that needs to be digitized and routed to the relevant departments such as legal, HR, and operations. It's relatively easy to scan receipts, to create digital images or PDF documents, and it's possible to use optical character recognition technologies to extract the text or contents from digitized documents. These forms might contain information that needs to be extracted and conceptualized, such as phone numbers, names, dates, addresses, and legal details. The Form Recognizer service in Azure provides intelligent form processing capabilities that you can use to automate the processing of data in documents such as forms, invoice, and receipts. It combines optical character recognition with predictive models that can be interpreted from data by matching field names to values, by processing tables of data, by identifying specific types of data. Now that we've seen various computer vision services available on Azure, let's take one of them for a spin, shall we? Join me in the portal. We find ourselves back in the Azure portal for another demo. So right now we're going to be doing the Analyze Images with Computer Vision. So for that, we need an additional resource. So let's go ahead and create that resource. We can either create the Computer Vision resource or the Cognitive Services General resource. But for this demo, I'm going to create the Computer Vision resource. So I do have some existing demos that I created before with resources. I'm going to create a new one for this session. Just follow the wizard. It's pretty, it guides you quite well. So for the resource group, I'm going to select the same resource group that we've been using the whole time, AI 900 Virtual Training. I'm going to deploy it in the East US region. And the name has to be unique. I'm going to call this Analyze Images AI 900 demo. Is this unique enough? Perfect. So once you see a check mark, it has allowed the name. And I'm going to have to use the standard resource type because I already have another resource that's using the free tier. So that's okay. It doesn't cost too much. And I think that's all the setup that you need, but you do need to accept the responsible AI notice because Microsoft does practice responsibility when building out AI solutions or allowing customers to use these AI solutions. So we do need to accept and acknowledge the above terms. And we can go ahead and create this resource. After I click review plus create, so our deployment is complete. Now we can go to the resource. So this deployment is no different from what we did in module 1, where we looked at the keys and endpoints for cognitive services. And that is how you're going to be able to consume this resource as well. So we have the keys and the endpoint. That is how we are going to be sending requests to this resource. And I'm going to use the Cloud Shell once again to carry out this operation. So let's go into the code editor and modify this code. So I'm going to go ahead and open the script that is relevant for this image analysis, and that is analyze-images, that is right here. And what we need to do is we need to replace the key and the endpoint with the data that is in our resource over here that we just created. So let me go ahead and do that. So copy the key and we replace it. And we need to copy the endpoint and replace that. So make sure no one is able to see your specific key and endpoint because it does charge you when this resource is used. I'm going to save this, save and close. So if you don't want to use the buttons, you can use the shortcuts Control S and Control Q to close that editor. Now we're back in our command line. And I'm going to deploy this resource. So now that we've replaced the key and the endpoint, we can go ahead and deploy this resource. And to analyze an image, we do have some images that are stored inside that GitHub repository that I'm going to be using. I'll show you how the image looks when I'm about to run that script. So first thing we need to do is we need to navigate into that folder. AI 900 -virtual training. Once we're in this folder, we are ready to run the script. But let me bring up the image so that you can see which image I'm going to be analyzing. So this is the image I'm going to be analyzing, and let's run the script and send this image to the endpoint. To run the script, I need to write analyze-image.ps1 space, and then the name of this image is store-camera-1.jpg. So I'm just going to make this window a little bigger because there's going to be quite a bit of content that it will generate. And when I hit enter, it's going to analyze this image. And it's going to tell me a bunch of things. It's going to give me a description of a woman showing her phone to a child. That's what's happening in this image. And we have all the other objects in this image. Things like cell phone, 2 people that have been recognized, the room, and all the tags. Things like text. So it found text somewhere, probably in the background, over here maybe on the labels, and the person that has been tagged, the woman, the store, and the shop. Let's try this again with another image. Okay, we've pulled up another image. I'm going to run the same script, but this time with image number 2. Let's see what happens here. And now we have a different description. So it has understood contextually what is going on in this image. A woman holding a shopping cart. So this is not exactly accurate. She is holding a basket, but it did recognize it as a cart because it contextualized based on all of the tags that it found in the image. and it found only just a person in this image and nothing else. So this could be due to the blur in the background or the angle where the photo was taken from. Let's give it one more try and see how well it performs. Let's try a third image. And here we have another image of a lady shopping at a supermarket, and let's see what our image analysis resource can provide. And here it says a person pushing a shopping cart, a little bit more accurate. And it found two objects, a person, the supermarket, and all of those tags. And you can begin to see this is a very simple example, but in the real world, you can see how powerful this could actually become. You could have an example or an application where safety is something that you can monitor, whether someone is wearing a helmet or not, or if a car is traveling at high speed, for example. When you compare from one image to another, that could be a potential risk. So all of these things can be done with image analysis. So let's jump back to our presentation and continue towards the end of the module. You can see how useful and powerful image analysis can be for applications like self-driving cars, safety and security, amongst many others. With that, we've come to the end of Module 3. In Module 3, we looked at concepts of computer vision and saw various applications of the technology in Lesson 1. And in Lesson 2, we looked at some Azure-specific services that can help you to build out solutions to carry out those workloads. I'd like to now send you off for another 10 minutes to ponder how useful a role AI might play in our future. And I'll see you back right here for Module 4, where we will be talking about another useful technology which helps computers to speak our language. Go get your coffee, tea, or drink of choice, and I'll see you soon for Module 4.